Hello everyone, welcome to another video log of Artica. Today I will be talking to you about how to learn to programming. We got a few questions asking us where should you go to learn how to programming and what you need to know if you want to program in projects related to physical computing itself. So globally or generally, you can learn how to program by either taking a course in a university or a workshop. You can also read a book, how to program. You can take the basics out of a book really easily. But nowadays we have the internet, and with the internet, there's a whole series of online tutorials and online videos which you can take advantage of. I can recommend two resources for you. One of them is khanacademy.org. If you go there, you have all sorts of video tutorials, not just how to learning to program, but also basics of mathematics, of physics, all different kind of stuff. Then you also have codeacademy.com, which is an online tutorial system. It gives you some tasks that you should accomplish. It explains to you how they are done, and yeah, it's a very good resource for learning how to programming as well. There are a lot of others. Just search Google a little bit, you will find some, so I will not spend much time listing them. What I want to talk more about is what you should be required to know to program when you're trying to do physical computing projects. So physical computing usually involves hardware and software stuff doing visual things. So you will have usually four components. One of them is the hardware and electronics, where you'll mostly be programming C, bare bones C, either to flash firmware of different components that you use on the boards that you make, or to program Arduinos themselves. Arduino is the best microcontroller out there, or the most accessible one. So it's highly recommended that if you want to learn how to program Arduino, or if you want to learn how to program hardware stuff, you should start with the Arduino and then scale from there. You can easily find them for sale everywhere, and also there are a lot of online resources on how to program for the Arduino and the workshops and such. Another topic that involves physical computing is the computer vision topic. Usually take an image from a camera somewhere when you have to filter it and give blob tracking or motion tracking values back to a graphic application. This can be easy, but it also can be quite complex. The most basic usage of computer vision doesn't require programming at all. You just need to run either TSPS and fiddle with the parameters there, trying to fine-tune it, calibrate it properly, or you run bonsai and you do these bonsai trees, which you can add elements to and change parameters on each of the little nodes of bonsai to give you the output that you want. We already did a video on TSPS, which will show up here. We're planning to do one on bonsai eventually, not sure when, but stay tuned for that. The problem with computer vision is that at some point you will want to make either a standalone application or some custom modules or nodes for these computer vision applications that already exist, and at that point you will need to learn how to program, and you will need to learn how to program specific computer vision things, and with advanced C++ and or C# knowledge base. So it runs up quite a lot. There are some people who specialize their whole life in computer vision things, doing face recognition, face tracking, detecting things. There's a whole machine learning aspect also related to computer vision nowadays. So there are a lot of things related to computer vision. It can be just a work of its own or a field of its own. Another point that we should talk about related to physical computing is programming graphics. And there are several ways you can get used to programming graphics. The first one and most accessible one is to program web-based things. For physical computing projects, you always or almost always have some sort of web page related to it, either to visualize the values that you got from your hardware or to control something, turn on and off some things. There are always some web-based things. The good news is that web-based programming, it's quite easy and accessible. There are tons of tutorials out there. You need to learn 3 different things, which is HTML, CSS, and JavaScript. JavaScript is the programming language in this. The other 2 are scripts, protocols. Not scripts. Well, yeah, kind of scripts. Anyways, web-based is relatively easy to get into. If you want to do more advanced graphical things like animations and interactive games sort of things, you need to learn to graphical computing things. And for that, there's a very good accessible language called processing. It was developed to help designers get into programming and creative programming in particular. So it was entirely designed for you. It's like a version of Java. It's not really Java, it's a simplified version of Java. So it's its own language called processing, and it really narrows down what you need to do to initialize your graphic environment and to update your graphical canvas on every frame. So it's a very good way to learn how to do the basic computing graphics things. I highly recommend you starting there, and then you can graduate to more advanced creative coding platforms. We already did a video of that as well. I'll also put a link here somewhere. There is Open Frameworks, there is libcinder, and if you want to use video game engines, there are also quite a few available. You have Unity 3D, you have Unreal Engine, you have CryEngine. All of these can be used to do 3D applications to synchronize with other stuff that you want to do with physical computing. Last but not least, you have the networking components. So networking is branches all of these different fields. It's like the glue that communicates between all of the different modules. And because of that, you will have to either program it on the Arduino using C or C++, or you will have to program it on web servers or the pages themselves, and that will either require you to know PHP, Python, or JavaScript. You will have to send back and forth HTTP requests, most probably, or establish WebSocket connections. So there's a whole different kind of things that you need to be knowledgeable about if you want to use this. And then there's some other services that you can also connect to, either send OSC values or send image or sound buffers directly to your applications. That can also happen quite often. So yeah, these are the main 4 fields that you will need to know if you are into programming for physical computing projects. What I wanted to mention is also that above learning from programming, you should have a reliable toolchain. This is mostly your development environment. You should, whatever development environment you're using, you should know how it works, what functionality it has, the shortcuts that it has. It can range from a simple text editor, like I give you 2 examples here, Notepad++ or Sublime. Notepad++ is only for Windows, Sublime exists for Linux, Mac, and Windows. Either of them are great text editors. You can also use the Arduino or processing development environment. Most of Arduino developers use the Arduino development environment. More advanced coding, you will be required to probably use Visual Studio or a clone of Visual Studio. There are a few out there. If you're doing Java, you will have to use Eclipse, or you don't have to use it, but it's a nice development environment for it. And then if you're doing graphical programming, you will also probably have to get used to Unity 3D, which is a visual environment of its own. And yeah, you should be used to these kind of tool chains, setting up your tool chains and using them for great advantage. Other soft skills that you are required when you learn to program is to look stuff up. Most of the time when you are programming, you are not actually looking at code, you are looking at documentation on how to do code or examples on how to do stuff. So get used to going to Google, looking stuff up, how to do this. There are millions, billions of people out there who are also learning to program. They go to the internet, they ask their questions there, other people reply. So you should take advantage of that and also maybe contribute, make the world a better place. Besides looking up information, you should be knowledgeable on how to debug the strange behavior that you have on your applications. And don't rely on others to take care of your bugs for you. Learn how to place breakpoints on your code, look at the stack values, write logs, do try catches, do everything you can to catch the errors earlier on and debug them and put them on the right behavior. Try to put simple code as possible, simplify code as much as possible, so that then it will be a lot easier to debug specific things. There are a lot of people who also are focused on doing test-driven development, where you write the tests for your code first and only then you write your code. It's another way of programming. I don't usually do that. I do the tests when I find bugs, then I write additional tests to debug them or make sure that everything is writing okay. Or when the code is specifically complex, then you write specific tests to make sure that the output is correct as you are expecting them. But it depends a lot on the size of the project and the way that you got taught how to program and what you are more comfortable with. Other relevant things that you should be aware of if you are learning to program. Physical computing has a lot of behavior trees things. Well, not a lot, but some of it. Behavior trees is another different way of programming. We use it a lot for programming robotic behaviors. It also gets used a lot for programming the behavior of artificial intelligence in video games. You basically give them some inputs, you set up a set of rules on how they are supposed to behave when those inputs are occurring, and you have the output out of that in a certain loop that makes the entity respond in a certain way. So this is important to get your head around as well, or interesting to get your head around. There are other things out there like visual programming, environments like MaxMSP, Pure Data, or VVV. You can do all the programming without actually writing code. You can just add boxes and connect boxes. Then you can do a lot of great things with that, so I can also highly recommend it. Also, if you're into programming, you will have to use the command line eventually, so you better get used to it. Learn the basic commands, learn to do basic scripting using it, either batch files or ch files if you're on Linux or Mac. It will come in handy for sure. Another issue that is important for all programmers out there is version control. It's great to back up your code, it's great to share it with the world, to open source it, to collaborate with other people, to keep track of the changes that you've been doing. So it's great overall. Also for project management is also useful. So get used to the tools that are out there. I use SourceTree, as you can see the icon right here. But you can use other services, or you can just use the command line for that. There are different kind of protocols for version control. Microsoft has their own. Then you have CSV, not CSV. That's comma separated value. VCS. I don't know, it's an old one, I haven't used it in a long time. The most recent ones are Git and Mercurial. They both work pretty much similar way. You can either go to github.com or bitbucket.org and you will find online free versions of that for open source projects, which you can use for your projects. You can also create your own server service for that and have version control privately. Another issue that you should be used to if you're learning how to program is how to do installers. At some point in time, the code will not work on your machine alone. You'll have to give someone a file that they can execute and install on their machine. If it's just a simple application, you really don't need an installer. Just double click the executable and it works. But when you start adding a lot of modules and the configuration of the computer itself, you will have to do installers, and for that there are several out there. There are some that are embedded directly into Visual Studio. Others have their own compiler linker to set them up, and it boils down to being a script in a specific language or system. It's usually XML, but it has its own specific configuration. And you will have to learn how to script it and how to give instructions that are correct. So it's another programming environment of sorts, which if you leave it for the last day before delivering this to a client, you will be in a deep pile of shit. So I will highly encourage you to get used to running your own installers, learning how they work, and testing things out. Another thing that's also important for programmers nowadays is provisioning, either if it's using virtual machines or a Docker environment. There are other alternatives out there to these, but basically provisioning helps you set up your development environment or your distribution environment in other machines easily without recurring to installers. So that's important also to get into. Oh, there's another issue which I haven't even mentioned here, which is not package. It's what's it called? Package management. Well, on Visual Studio you have NuGet. On Node you have npm. So the package management is a way for you to handle dependencies. When you are including a library in your project, you usually require a dependency for that. So how they manage to, and it's usually very problematic to deploy a project elsewhere without also taking all the dependencies, either already compiled or pre-compiled if you're still in development phase. So what some services are doing now is providing a system where you define a file saying, okay, my project depends on this file with this version, this file on this version, and you say the specific versions, and then you just run the install command, and it goes into the internet, fetches all the dependencies, installs them locally on your project, and the project is ready to run. This is getting more and more traction, and it's a nice, cleaner way for you to organize your project without going through the dependency hell and writing a lot of documentation on all the things that you need to install before your project is ready for compiling. This is semi-advanced stuff, but you will have to deal with it eventually. So I will advise you to start early and get used to it. Once you get used to it, it's quite easy. All of these technologies are not, they are meant to be as simple as possible. Of course, there is always a learning curve, and there are a lot of different options which you have to explore and figure out which one is the best for you. And but the main issue is that whenever you go work on another project, people tend to use slightly different tool chains and these kind of services. So you'll have to get used to a little bit of all of them, or at least understand the logic of them, so it's easier for you to get used to it. So that's a point that you should keep in mind when learning how to program. You will also have to learn how to get used to these kind of tools and use them wisely and use them often. Okay, that's it. I think I have nothing else to say. It's already been quite a long video. Let me know if you have any comments. I will also post a link to all the previous videos that we have done in this video log series. They will be up here somewhere. Let me know what you think. If you have any comments, any questions, if you want us to do specific videos on anything specific related to physical computing, we will be happy to do a specific video for you. So just let us know. And yeah, that's it. Bye bye. Take care.